Okay, now I'm here to give you a couple hints to deal with problem 91 on homework number 7 from page 379. Again, as you can see, I've drawn the picture here, but this time we have to do something a little bit different than we had to do in number 89. In particular, we have to find out the rate, we have to find the formula for the height of the object. Remember, the object is falling, so the height is going to depend on time. It's going to take some time for this thing to fall down this way. So this is the trickiest part to this problem. Part A is to find the height of the function. So recall that the acceleration of the function in feet is minus 32 feet per second squared. So once we have the acceleration, we should be able to learn that the velocity is the integral of the acceleration, which is the integral of minus 32, which should be minus 32 t plus some constant. And remember, that constant is the initial velocity. And this thing was not thrown down at any rate, so the initial velocity is 0. Now we can get height of t as the integral of velocity, which is the integral of minus 32 t. And this is equal to minus 16 t squared. So that's 32 divided by 2 is 16, and then plus c. And notice here that c is the initial height. So finally we find that h of t is minus 16 t squared plus 256. With that formula, we should be able to then determine how long it takes for the thing to hit the ground. Now the problem becomes fairly similar to number 89. Notice again, tangent of theta is h of t over 500, and that's the same as arctan h of t 500 is theta. So finally, we should be able to use this to solve d theta dt, and the only thing we have to remember is our chain rule, 1 plus h of t over 500 squared times the derivative of h of t over 500 is h prime t over 500, and that's it, because that already takes into account the derivative with respect to t. So finally then, we have to be able to solve h of t and h prime of t at the given times. T equals 1 and t equals 2. So that's your hint, and I hope it helped out.